Before we can learn how to navigate over the Earth's surface, we need to understand how it evolved into the familiar spherical blue planet. This lesson will describe the form and shape of the Earth, and how the Earth is spinning in orbit around the Sun. The Earth evolved from gas billions of years ago. A swirling ball of this gas then cooled and solidified to form the planet. As the gas solidified, the centrifugal force created by the spinning produced slightly more mass around the middle, and it became a distorted sphere. The Earth, therefore, is not perfectly spherical. It is slightly distorted, being more wide than it is high. This difference in diameter is called the Earth compression. The compression of the Earth is described in terms of its height, the polar diameter, against its width, the equatorial diameter. The polar diameter is some 27 statute miles less than the equatorial diameter. This equates to 23 nautical miles, or 43 kilometers. The difference between the equatorial and polar diameter can also be expressed as a percentage of the equatorial diameter, and this is 0.3%. Or as a fraction, it is 1/300th. The Earth's shape is referred to as an oblate spheroid. The Greek word for Earth-shaped is geoid, and this is sometimes used to describe the shape. There is a slightly larger amount of mass in the southern hemisphere, although this is insignificant in navigation terms. With ever-increasing technological advancements in avionics and navigational equipment, the significance of standardized models of the Earth is progressively more important. Many organizations in different countries throughout the world have produced independent models which differ in detail from each other. Modern navigation systems, for example those using satellite information, have position automatically corrected for the shape of the Earth. To have lots of different interpretations of the exact shape of the Earth could therefore be problematic and confusing in a global aviation network. A single model is needed, and the International Civil Aviation Organization has adopted the Earth Model World Geodetic System 1984, and this has become the standard model used for navigation around the globe. This Earth model is referred to as WGS 84. We have seen that the Earth is not a perfect sphere, with its equatorial diameter being greater than its polar diameter. For most of our calculations, however, we will now assume, for practical purposes and ease of explanations, that it is fundamentally a sphere. The Earth spins about an axis, called the polar axis. Additionally, the Earth orbits around the Sun, in an elliptical path, taking 1 year to complete a full orbit. An important factor of the way the Earth is spinning is that it is not spinning in an upright sense. In other words, the polar axis is not perpendicular to the plane in which it is orbiting the Sun. You can see in this diagram that the polar axis is not perpendicular to the orbital plane. The polar axis is inclined towards the orbital plane by an angle of 23.5 degrees. This angle of inclination is often referred to as the tilt of the Earth. We have seen that the Earth spins about its polar axis. The two extremities of this axis, where the axis meets the surface of the Earth, are significant points in the understanding of navigation. The two extremities of the polar axis are called poles.